Hi, I'm Thomas Thyen. I'm a Cloud VMware Solution Specialist in the Technical Cloud Organization of Oracle, mainly focusing on Oracle Cloud VMware Solution and disaster recovery, migration, and data center exit projects.
Hello, my name is Jeffrey Patronik. I'm Vice President of Sales for Atos Unify in North America. We are the Unified Communications and Collaborations Division of Atos IT Solutions and Services, and I will be highlighting a use case using the Oracle Cloud VMware Solution we'll be talking about today.
Hi, my name is Luiz Domingos. I am the CTO and head of portfolio for Atos Unify. I'm located in South Florida, and glad to be here talking to you all.
Okay, so this is a presentation about Oracle Cloud VMware Solution, sizing and scaling best practices, and a customer use case. And starting off with that, I would like to give a quick solution overview about what Oracle Cloud VMware Solution is. Oracle Cloud VMware Solution, or OCVS for short, provides the ability to run your current VMware workloads on bare metal hosts within Oracle Cloud data centers worldwide. So at the moment, this service is available in 40 of our cloud regions. And basically, our VMware offering includes the VMware software stack, including the vSphere hypervisor ESXi, the vCenter server, which is the management layer, VMware vSAN, which is the software-defined storage solution, VMware NSXT, this is the software-defined networking solution, and HCX in the advanced edition, that's a kind of cloud hybridity solution that can be used for migration and small disaster recovery solutions. The whole software bundle is packaged with Oracle Cloud VMware Solution with full support and licenses for the mentioned products. From the Oracle Cloud infrastructure view, we are offering bare metal servers, either based on Intel CPUs or AMD CPUs in different shapes. So the Intel bare metal shapes come with 52 cores and 768 GB of memory and 51 TB of local NVMe storage. And our AMD shapes can either be deployed with 32 cores, 64 cores, or 128 cores, with each 2 TB of memory and 54 TB of NVMe local storage. From the deployment options, we have two options at the moment. One is a single host deployment. This is actually used for proof of concept environments, test and development environments that do not require any availability SLA. And when it comes to production workloads that you want to host on Oracle Cloud VMware Solution, the minimum deployment that you have to go for will be a 3-node deployment. And this can actually scale up to 64 hosts in a software-defined data center. Talking about the scaling, we have a quick overview about the minimum sizings for the different types of shapes that we offer. For the Intel shapes, and minimum deployment of 3 nodes for production workloads will have 156 OCPUs, 2 TB of memory, and 122 TB of vSAN storage that we can provide in a cluster. For our AMD models, we can either go with 96 OCPUs by choosing the smallest shape, which is the DensIO E432, or the 64 shape with 192 OCPUs and up to the shape with 128 OCPUs, which will provide 384 OCPUs within the cluster. Each cluster itself with the 3-node deployment comes with around about 6 TB of memory and 130 TB of usable vSAN storage. From the sizing perspective, we have many factors that are influencing the sizing of an Oracle Cloud VMware solution. At first, I like to start off to give you an introduction into the storage layer that is influencing the sizing. Based on our ESXi hosts, we have a construct what is called vSAN disk group. So this is a common construct which is essential in VMware vSAN clusters. So basically, what we are utilizing here is the 8 local disks that we have in each ESXi server. And one of the disks is used as a cache device, and the other 7 disks are used as capacity devices. So the capacity in devices in this case represent the amount of storage per host that is available to store virtual machine objects. So for the Intel-based host, for example, it's 7 times 5.8 terabyte, which will result in 40.74 terabyte per host, and then actually results in the end in 122.2 terabyte of vSAN raw capacity in a 3-node cluster. We basically have the same scenario for AMD hosts. The disks are a bit larger, and in the end, we will end up with around about 130 terabyte of usable vSAN raw capacity within AMD clusters. But in the end, there are several more factors that are influencing the sizing of an Oracle Cloud VMware Solution cluster. For example, basic vSAN parameters like the failures to tolerate, or called FTT, which basically determines how many hosts in a cluster can fail, 1, 2, or 3, for example, and vSAN will guarantee that when you're selecting a policy like this, that at least 2 or 3 hosts can fail in a cluster, depending on what level you select, and your data will still be available. The next parameter that is influencing the sizing is the fault tolerance mode, or FTM. And this is basically the rate level that you're choosing to host your virtual machines. It can either be rate 1, it can be rate 5, or rate 6. And basically this determines in the end also how much host you will need in the cluster to distribute your data. Another important factor when it comes to availability of services is spare hosts that you want to have in your clusters. When it goes to production workloads, you either want to have at least 1 spare host or 2 spare hosts when it comes to really critical workloads, to be always sure that your data will be available and that you have enough failover resources to host your virtual machines. Some other parameters like operations reserve and host rebuild reserve are VMware vSAN parameters. Operations reserve by default comes with 10%, and the host rebuild reserve is based on the number of hosts in the cluster. So basically, you're dividing 100% of the resources by the amount of hosts. If it is 4 hosts, then actually the host rebuild reserve will be 25%. And together, this 10% and 25% will build 35%. And actually, the maximum value that you can set here is 30%, which is the vSAN maximum. So this is then a space that we are reserving on a vSAN data store for maintenance and rebuild operations. From the space-saving technique standpoint, we provide deduplication and compression. So you can either select deduplication and compression or compression only. It really depends on the workloads that you are hosting. And of course, also the CPU oversubscription and maximum host utilization. So with oversubscription, we are just meaning that how many vCPUs you can run on a physical CPU. Is it 1 to 2, 1 to 3, 1 to 4? And basically, the maximum host utilization is just determining that you cannot run your VMware vSAN host at 100% utilization. So the baseline that we are setting here normally is 80% utilization of the CPU and memory resources to make sure that you still have enough failover capacity and rebuild capacities in place. Workload type and on-premises CPU utilization also play a big role because different types of workload virtual machines have different types of deduplication and compression levels. And yeah, of course, if we know that the vCPU utilization on-premise is 90%, which could be a very high utilization, then we probably have to account for in the cluster that we at least can met this 90% of CPU utilization within the OCVS cluster as well. So we have to plan resources accordingly for that. And actually this CPU utilization in the end will influence the CPU oversubscription ratio. And actually when collecting all these parameters, you are ready to go into an OCVS-sizing, which we will come to later on my slides with an OCVS-sizing example. The next case is to give you a bit more feeling about what fault tolerance methods and failures to tolerate really mean is that we are going to show you how the the selection of the fault tolerance method and the failures to tolerate level will influence the amount of storage that you need in a vSAN cluster. So with this example, we are taking virtual machine objects with 30 terabyte into account. And in our example, our vSAN host has a capacity of 40 terabyte. So when we are looking at the slides and going to the first method that is highlighted here, RAID 1 mirroring with failures to tolerate set to 1, the minimum host count that we need is 3 hosts. So in total, our vSAN cluster will have 120 terabyte of capacity. But basically, we have to store 30 terabyte of virtual machines in a RAID 1 configuration, which means mirroring. So in this case, if the failure tolerance method and the failures to tolerate are set to 1, the consumption on the vSAN will be 2 times. So we have to double the 30 terabyte into 60 terabyte, which in the end results and that when we are hosting these virtual machines, that we are using 50% of the vSAN storage, and we just have 50% of free storage. If we do similar configuration in an RAID 5/6 erasure coding configuration with 2 failures to tolerate, in the end, we will end up with 6 hosts, so a total of 240 terabyte in our cluster, which brings a higher level of availability and resiliency. In the end, we will just end up with 90% consumption and 81% free space. This is due to the rate mechanism in the end, because the consumption in the end is 1.5 times. So the 30 terabyte VMD case will turn into 45 terabyte vSAN consumption in the end. So what we see here is in the end that the fault tolerance method in combination with the failures to tolerate you're going to choose in your OCVS vSAN cluster will have a big impact on the overall sizing of your cluster and probably also on the scaling of your cluster. And to give that a bit better overview, we have this visualization of how the storage policies work in the end. For example, what I was talking about earlier before, the virtual machine marked in blue with a fault tolerance method of RAID 1 and failures to tolerate set to 1 will at least need 3 hosts. So as we can see here, the data disks, the blue ones, are distributed across host 1 and host 2, and then actually on the third host, we have a witness for the RAID and for failures to tolerate. And actually, this witness in the end is more or less working as a tiebreaker to really check if all the data is available, and if not, if the data has to be rebuilt on one of the hosts in the cluster. When it comes to RAID 6 with failures to tolerate set to 2, as you can see, we already need 6 hosts in the cluster because we have to store the data copies on 4 hosts, and we need 2 parities. And actually, the same goes for RAID 1 with failures to tolerate 3, where we actually need to have 7 hosts at minimum to distribute the data across 4 hosts, and we have 3 witnesses in that case to really make sure that we can tolerate 3 host failures in the end. The good thing here is, in the end, you can combine all these storage policies, different RAID levels and failures to tolerate levels within a cluster. In the end, the highest level of failures to tolerate and RAID level, which is RAID 1 and FTT set to 3, will determine how large the cluster has to be, in this case, a minimum of 7 hosts. As I was talking earlier before, we are going into a quick sizing example about Oracle Cloud VMware Solution. So we get a few requirements here from a customer scenario, which we had in the past, where the customer had 280 virtual machines with a total of 620 vCPUs, 4,500 gigabyte of memory, 60 terabyte in RAID 1, and 120 terabyte of virtual machines in RAID 5. The availability requirement was N+1, and the customer was working with a CPU oversubscription of 1:4. And actually, what we are counting here also is the OCVS management layer, which is the vCenter server, the NSX managers and edge nodes, and actually the HGX appliances as well, which come with 70 vCPUs, 207 gigabyte of memory, and 2.56 terabyte of vSAN storage. So in the end, this brings us to a total compute requirements that we have of 690 vCPUs, 4,707 gigabyte of memory, and 296 terabyte of storage. Basically, what we are doing in the first phase is we are creating a table with all our shapes and noting down the details of the shapes. In this case, I highlighted the VM Dense IO E4 128 32 shape. So this is the AMD shape with 32 cores. And as you can see, we have 2 sockets with each 16 cores. And this results in 32 cores in total. And basically what we are using is the CPU oversubscription ratio of 1 to 4. So we are taking 4 times the 32 logical cores, which turns into 128 vCPUs that we can use on this host. And as I mentioned before, as a baseline, we are taking just an 80% utilization of vCPU memory. So in the end, these metrics result in 102 usable vCPUs and 1,638 gigabyte of memory that can be actually used for virtual machines. And this is really essential for the later sizing exercise. Based on that, we can start with our calculation. As we know, the highest level that we have in this cluster will be RAID 5. So from this, we know directly that we need a minimum of 4 hosts. And actually the requirement was to have N+1 availability. So we know in the end, the cluster must have at minimum 5 hosts. If we end up in the calculation with less than 5 hosts, we have calculated something wrong because that's not possible because of the RAID level. And based on that, we are starting our calculation, which is pretty easy in this case. So with the 63 terabyte and 120 terabyte, which will result into 126 terabyte and 160 terabyte, depending on the RAID algorithms. And this will give us a total of 266 terabyte of raw data that we have for the virtual machines that we have to store. And with a deduplication factor of 1.5, we can bring this down to 191 terabyte. So this is actually the baseline that we need to store on virtual machine data on our vSAN cluster. In the next step, we are taking the VMware vSAN host into consideration, where we know the actual host capacity is 43.26 terabytes. And then we are subtracting the operations reserve and host rebuild reserve, in this case, 22.5%. And actually, we will end up with 33.5 terabyte of local capacity host that we can use. And basically, from that on, the calculation is pretty easy. So we are taking the overall consumption, the 191 terabyte, dividing it by the vSAN capacity, so the 33.5 terabyte. And basically, we will end up with a baseline of 6 hosts. And if we look at the table above, with 6 hosts, we will get 612 vCPUs. And actually, this is not meeting our requirement that we have, because our requirement for vCPU is at minimum 690 vCPUs. From the memory and vSAN, we are totally fine, but we cannot satisfy the vCPUs here. So for an N+0 configuration to have a minimum requirement, we need at least 7 hosts in the end. And really, to have an N+1 requirement in the end, we have to add another one, which will end up in the end with 8 hosts, which will guarantee us 816 vCPUs, 12 terabyte of memory, and 346 terabyte of usable storage. So we still have some failover resources and room for expansion in the future. With this, I would like to come to the scaling options of Oracle Cloud VMware Solution. And I already mentioned this earlier. So OCVS in general is a scale-out solution. We also call this horizontal scaling. So storage and memory and CPU generally at this point in time can only scale horizontally. So this is just by adding another ESXi host, another bare metal host to your OCVS cluster, so that you can scale out. we will bring in a new feature in the near future, which allows vertical scaling of the CPUs for AMD shapes. So you can then scale from 32 to 64 cores, for example, or from 64 cores to 128 cores, just by setting the host into maintenance mode, doing the setting in the OCI console, and then rebooting the host, and then bringing it back to the cluster. So this then brings the opportunity to scale CPU resources vertically if there's the demand to extend the CPUs on the ESXi cluster. Basically, when it comes to cluster types, we offer two types of clusters. The normal mode of cluster is our single AD cluster, which is the most commonly used cluster model that we see. So this is just a basic VMware vSAN standard cluster, which is stretched across 3 fault domains within one availability domain. So an availability domain is a data center, and the fault domains are fire zones or racks within the data centers. So in our case, our 3-node cluster is spread across 3 fault domains, where each OCI fault domain will represent a vSAN fault domain. The other pretty unique feature, which is only available on Oracle Cloud VMware Solution, so no other cloud provider in the market can offer this feature, is a multi-AD cluster, where our vSAN standard cluster is stretched across 3 data centers or 3 availability domains, how we call it. In this case, the availability domain or the data center will represent the vSAN fault domain, which then brings the opportunity that you can manage this cluster like a normal standard cluster without any performance trade-offs. And this is actually a solution that our colleagues from Atos have implemented together. And with this, I would like to hand over to Jeff Patronik and Luiz Domingos, and they will tell you more about their solution.
Great, thank you very much, Thomas. I thought that before we dive into the review of our relationship with the Oracle team and the technical details that you'll hear from Luiz on how we've leveraged the Oracle Cloud VMware Solution, we thought it would be helpful to at least give you some context of Atos Unify, the market we serve, and the primary market trends that influence the nature of our relationship with Oracle. But first, a bit about us. So we're an organization with a real deep history in communications and collaboration. We provide massively scalable carrier-grade platforms supporting the communications requirements for our large enterprise customers, mission-critical communications infrastructures for deployments such as what we've done for the state of California and their NG911 deployment, and also use cases within the Department of Defense for command and control. We really have a well-oiled machine here with our product house led by my speaking partner, Luiz. And we do boast a regular stream of patents, which you see there. We support tens of millions of users and devices annually, and the synergies that we have with some of our leading technology companies and partners and other organizations, speaks for itself. So we really believe it's our tenacity that helped us deliver this communications technology to our customers through what they're going through right now, these transformations and this disruptive technology. And of course, today's obsession with what everyone terms the cloud, it's really no different. So to give you some more context of how the industry is changing and what we've faced and how we're forcing the debate about cloud, I'm going to advance it to my next slide. So let's look at a few of these trends. Okay. So, to give you a look at the priority demands from our clients, and to be perfectly frank, the guidance we are giving them is likely not too different from many horizontal functions in a business. So, but because of the nature of communications its disruptive potential as new technologies emerge, especially in the Internet of Things space, as business models change and how how we communicate to and with them, how the deepening focus on differentiating our value, and how we believe communications contributes to this landscape is what we saw in the potential of this. So, our goal, we want to be global, but we have compliance requirements, and that means a standardized approach isn't sometimes good enough. There's all kinds of compliance around data sovereignty and how that puts pressure on the public cloud, how marginalized communications experiences, we believe, are woefully insufficient for the diverse workflows. And I mean, think about employee safety and, like I mentioned before, mission critical communications and the frontline workers. So to kind of net it out, innovation is the key, and that is, in the communication technology that we offer, and we help leverage the communicative power from this diverse entity of frontline workers. Okay, so and in the middle, of course, you see the blockers, right, to achieving this the total communications potential. All right, and then you start questioning, all right, well, which cloud is the right cloud for me, since they all have similarities, but they all do in turn offer unique things. So we experience this exact same thing ourselves. And our challenge really pertained to a key client that was approaching end of life, that we were going to be moving off of our legacy technology. So we provided them this solution. And to go into more detail about this, I'm going to hand it over to Luiz Domingos, who'll provide a little bit more of the background and how we move forward with Oracle. So I think it's really exciting and really informative. So with that, I'm going to turn this over to Luiz Domingos. So Luiz, it's all yours.
Thank you, Jeff. And yeah, it's a very important question what you're raising before. What is the right cloud for our customers and business needs? For us, the starting point was the existing hosted service data center model that has been around for a number of years, delivering services to our UK government customer and some commercial customers over there. This model evolved during a long period of time, but the underlying infrastructure was coming to the end of its usable life. We're faced with choices. Yeah? So what we do, either upgrading the existing infrastructure at considerable expense, ceasing the existing service model completely, or exploring new deployment models. This was the beginning of our journey, and we're looking at alternative infrastructures. And in this process, we engaged with the top hyperscaler vendors, including the usual suspects. And we brought them unique requirements. At Atos Unify, we supply end-to-end capabilities for communication solutions, including UCaaS, contact centers, vertical applications for mission-critical customers. This includes also legacy applications side by side with new requirements towards compliance recording and new vertical applications, with a mix of legacy and new applications. Our technology has also strict demands for real-time. Communications is a real-time business, and dedicated infrastructure resources to transport live media. Some of our businesses are 24/7, don't tolerate downtime at all, and expect application network resilience and redundancy with geographical separation. This gives you an idea what was the requirement of our business. It's not trivial from the infrastructure perspective, and a challenging endeavor to a good degree. The main challenges we faced was to resolve issues with scalability, application modernization, and automation of services. And we had to handle all of this within a tiny predefined business economic perimeter, which was dictated by the existing hosted solution. So financials were already kind of under control, under limits for us. On the next slide, I'm showing basically how we come from these requirements for the business into our decision to select Oracle. So we started working with Oracle and found in them a hypervisor vendor willing to closely collaborate with us to tackle the challenges. The decision to select Oracle was based on three main parameters. First, industry fit. In contrast with other vendors, we were able to tailor the solution with Oracle and VMware and deploy as a private cloud, which is the more secure solution for governments and mission-critical business like emergency solutions, emergency communications, and healthcare. In a positive sense, regarding security, Oracle is hands-off in this environment because we have full control of the security keys for the solution, and we operate independently of the rest of the cloud infrastructure. We also don't have to share resources, which reduces availability risks or delays that can be disastrous when delivering UCaaS. And we still kept the flexibility to expand and adjust capacity as needed for our customer solutions. Also, we observed that the deployment via Oracle resulted in halving the time to deploy an instance. For us, this means less service cost, increased efficiencies, and we could realize revenue quicker. We also saved additional costs by improvements in the resource utilization polling. Last but not least, very relevant to us was the support we received from the Oracle team, from VMware, in the process of familiarization with the infrastructure, designing the solution architecture, dimensioning sizing for our app's needs. And as you can saw from Thomas, dimension is a complex exercise, and we had a lot of support to it. And they helped us through the various stages of setting the whole system up. I added some data analytics here as a result of the dimensioning sizing exercise. And as example, we had 7 bare metal instances, over 100 virtual machines hosting 132 applications. So it's really a large configuration as far as we're concerned, and is already in operation in UK. Now, if you switch to the next slide to see the architecture, we selected the Oracle architecture delivers a scalable service model. We know that, and supporting multi-tenancy, large scalability, and spare capacity to support additional new customers in usage peaks. Despite the multi-tenancy capabilities, we decided to start with multi-instantiation of customer solutions to ensure full isolation and security of customer deployments, which is expected by many of our mission-critical customers. As presented by Thomas, we're using the following architecture services. We decided to go with the Oracle VMware service with a combination of the Oracle and VMware infrastructure. And we picked the AD cluster model and deployed 3 availability domains, one in London, we call it UK Central, one in Newport in UK called UK West, and we delivered a third one. We established a third zone in the Netherlands, which is currently as a backup that we plan to use in the future. In addition, we have a fully meshed connectivity between Oracle and Atos services. Oracle provides the provisioning of OCVS, but we manage everything, so we have full control of our instances within OCVS. And we also implemented PSTN connectivity for call traffic routing, which is key for telecommunications. And we also instantiated the Network Operations Center, which is very key to manage the day-to-day of the business, including system administration functions. Now, when we take the next slide and look at how this architecture is applicable to our applications, you can see all the applications that we have on the right and how we fit into the architecture. On the application level, we're able to address all customer requirements that were more or less full identity management control, app security and encryption, properly distributed across the 3 deployment zones, customer shared infrastructure via fully separated tenancies, and application deployment in redundant operation. And we continue to add more capabilities and migrating applications and services to Oracle, following natural progression to improve efficiency of our solution. We also have identified a number of additional opportunities using the Oracle Apex suite, which will allow us to further enhance our service offering with analytic portals and pricing tool definition, which are currently under investigation. When you look at the next slide on the current mode versus final mode of operation, So this is where we come from and where we plan to be at the end of this whole migration. We moved from a data center dedicated server farm with all sorts of equipment, servers, network routers in a non-uniform structure towards a tiered approach with the user apps and telephony connectivity layers and the harmonized private cloud deployment with OCVS, hosting our telecommunication applications. To our customers, we offered deployment flexibility for the customers that want cloud but don't want public cloud offerings deployment due to compliance. We provided the highest security requirements. We attended those. And as a consequence, we provide a more versatile OPEX subscription model in contrast to previous upfront perpetual licensing. We also avoided full rip and replacement for customers with existing Unify investments that wanted to retain carrier service control, number retention, and some of the telephony features that are so vital for them. And last but not least, we gave our customers assurance and operational availability of their mission-critical applications, which is priceless in our business. We're very pleased with the outcome of this migration. And now I'll just hand back to Jeff to talk about the business benefits.
Yeah, thank you, Luiz. That was pretty informative, and thanks for taking us through the technical modeling and some of the issues and challenges that we faced. So to kind of come into the home stretch here, as we look at the overall benefits that we've experienced working with Oracle, I think first and foremost, we were able to realize that the outcomes that we planned on and that we expected actually came to fruition. And many of those benefits we realized, such as the resiliency that is paramount in the communications platforms and solutions that we offer to our end users and our customers. We really needed that cost-effective model, not only for us, but that we could then pass on to our customers for additional savings. The scalability was critical for this, not only for the plans that we have today, but also for tomorrow in the future. And then, as you heard Luiz mention, the independence of this, being independent is critical to the nature of a lot of our client relationships. And that's simply due to the fact that we have our own compliance needs as a global organization and our own expectations on top of those. It was very key for us to build the upfront and identify and define the upfront build costs of this, and then equate it, as you heard Luiz say, into an OPEX model for the monthly subscription. The resiliency of this was especially key, and that's really what Oracle delivered, right? They provided us at Atos a highly secure, much scalable and dedicated platform for all our critical workloads we embed on OCI. The underlying highly secure OCI infrastructure, that is operating in the VM core, with encryption implemented everywhere across this, across OCI and VMware, and the core really operating as a standalone, unit, really encapsulated the platform within OCI. So that's why we're excited about it. The Atos Cloud Platform, as we named it, it's purpose built, within the VMware environment, adopting all the latest technologies and the product set coupled with the feature-rich OCI framework. So for us, it was an excellent commercial fit compared to what we were looking at with the existing costs. The ability for us to support a consumption-based model was critical. And, our customers are asking for pay-as-you-go, right? So that's what was extremely cost-effective for us. And the onboarding time to bring customers to this platform was within our our anticipated delivery windows and what the customers were expecting. We also like it because of the growth capacity and potential, the extensibility, if you will, right? Virtually unlimited scalability for multiple use cases, and being able to customize this for certain customer needs. All right, so the speed to market and the growth potential really helps us with our revenue recognition faster. We get clients on the platform sooner, and then it helps them to deliver services to their clients. So, and then the independent nature of this we have for compliancy and from Oracle. So that's the exciting piece. And as I kind of take it into the home stretch here, we really wanted to imbibe to you the really a framework to ask questions of your key users, right, and among yourselves. Are we ready for this type of journey? Is communications and collaboration, is the UC space within your organizations ready to move to a public cloud that is potentially more secure, more resilient, more private, if you will, right? So we believe with the Oracle Cloud VMware Solution that delivers that quite elegantly and quite cost effectively and quite richly. And we look forward to having these follow-on conversations with you. And with that, Thomas, I believe it's time for our question and answer period. So that concludes the end of my slide. Back over to you.
All right. Thank you very much, Jeff. And actually, with that, we are coming to the end of our presentation. And actually, first of all, I want to thank you, Jeff and Luiz, for presenting this great showcase. And also thank you to everyone who is going to watch this session. And if you have further questions, you please feel free to contact your Oracle sales representatives. And actually, they will then work with our account cloud engineers and with our specialist VMware team to work on the right VMware solutions for you. So with that said, thank you very much. And this is the end of the session.
Thank you.
Thank you.